There are lots of different applications of solving right triangles. One of them is if we're talking about angles of elevation or angles of depression. And here's kind of the formal definition for an angle of elevation and the formal definition for an angle of depression. To me, it's easier to see it in a picture. So an angle of elevation means that you're going from a horizontal up to a point, and the angle from the horizontal up to the angle that that point would give you is the angle of elevation. For an angle of elevation, you're always going from the horizontal up. For an angle of depression, for that you're always going from the horizontal down. We would have a horizontal, we would have a point down here, and the angle that we form by that is the angle of depression. And since we're talking about triangles, we're never worrying in this about having negative angles. We just consider every angle to be positive. But just remember for this, both of these types of angles are measured from the horizontal line. We're going to have some application problems to solve. So here's some basic steps for solving application problems in Trig. The first one is whenever you possibly can, draw a sketch. That's going to help so much. I don't know how you could solve most of these problems without having a sketch of it. So draw your sketch, label it with any information you have, figure out a variable for the quantity you're trying to find, and label your sketch with that variable. Next, find an equation that relates the quantities that are given to the variable you're trying to solve for. And then finally solve the equation. And last of all, check that your answer makes sense. So at the very least, check that it's reasonable. Here's our first application problem. And in this one, you have to read really carefully. So it says, Pat knows when she stands 123 feet from the base of the flagpole, the angle of elevation to the top of the flagpole is 26 degrees 40 minutes. If her eyes are 5.3 feet above the ground, find the height of the flagpole. So I started out with a simple sketch here. So here's Pat. Here's my flagpole. I know this is 123 feet from here to here. And then said the angle of elevation to the top of the flagpole is 26 degrees 40 minutes. So I'm going from the horizontal here up to the top of the flagpole, so that angle is 26 degrees 40 minutes. If I have this sketch and then I go back and read the problem again, I see, oh, there's this other piece of information. I didn't include that in there anywhere. This says her eyes are 5.3 feet above the ground. So the angle of elevation is actually figuring from her eyes the line of sight to the top of the flagpole instead of from her feet. So the base of the triangle we're trying to solve should actually be 5.3 feet above the ground. This sketch is not right, so I redrew this. Now I've got still the same distance from her to the flagpole, but my triangle is starting up here at 5.3 feet above the ground. The angle of elevation from there to the top of the flagpole is the 26 degrees 40 minutes. Now what this adds in is a little bit of complication, because when I'm trying to find the height of the flagpole, it's going to be this 5.3 feet plus whatever I find for this distance here that I've got labeled x. But first I need to solve for x. Looking at the quantities that I know the angle, and I know that the base of this triangle is 123 feet. For the function that relates this distance and the angle, that would be tangent, because tangent is opposite over adjacent, and this is the opposite and this is the adjacent for this angle. Here's my equation. The tangent of 26 degrees 40 minutes would be x over 123. I can solve this by multiplying on both sides by 123, so I get 123 times the tangent of 26 degrees 40 minutes equals x. When I calculate this out, I'm going to round it to 3 significant digits, because that's how many digits my 123 has, and that's how many digits my angle measure has. So this is 61.8 feet. Then to get my final answer for the height of the flagpole, I have to add the 61.8 to the 5.3. And that will take it all the way from the ground to the top of the flagpole. So when I add those two together, that gives me 67.1. And notice that my 5.3 was actually 5.30, so that one did have 3 significant digits also. Here's one more example. This time we've got someone on the top of a 210-foot cliff, and he sees a lighthouse that's 430 feet offshore. So it's 430 feet from the cliff to the lighthouse. And we want to find the angle of depression from the top of the cliff to the base of the lighthouse. So this time we want to be sure that we're drawing the picture right in the first place. This says we're going from the top of the cliff, not from where his eyesight would be. So here's my picture. I've got the cliff over here. It's 210 feet tall, and it's 430 feet over to here where the lighthouse is. And what I'm trying to find is the angle of depression. And remember, the angle of depression goes from a horizontal down. Here's my horizontal up here, and my angle of depression is going to be this one. So I can relabel this distance on the top of this triangle with the 430 feet, and I know that this side over here is going to be 210 feet. Now I'm trying to find this angle of depression, which I called that one D. For this angle, the 210 feet is the opposite side, and the 430 feet is the adjacent side. That relationship would be tangent. So that tells me that the tangent of my angle is 210 over 430. To solve this for D, I'm going to use an inverse tangent function on both sides. So I've got inverse tangent over here and inverse tangent over here. On this side, these two are inverses of each other, so they cancel each other out, and we just have D. And over here, again, I'm not doing this division first. I'm putting it in my calculator just like this. So I'm doing inverse tangent of 210 over 430, and that gives me 26 degrees. This time I'm rounding to 2 significant digits, because if I look at these measurements, these were both to the nearest 10 feet. So those only have 2 significant digits, and I'm rounding this one to 2 significant digits. The answer to my question is that the angle of depression is 26 degrees.